Hello, welcome back with another tutorial. So today we're going to talk about greebles and greebly design. So what I mean by greeblies is, I've explained this in class over and over again, is basically modular or non-modular items that can be used for set decoration. They can have low detail, they can have high detail, but they are meant to fill up the areas in between highly repetitive elements in your level design and add some variation into the general environment design. So let's get to it. In order to start designing greeblies, you have to start with, as always, references. And the best way to go about doing that is that even if you do not have premium credits and unable to download any of the pictures here, this is still a great reference page because you don't have to download anything. You just want to check them out very briefly. And textures.com is a perfect place for that, but you can search for other references as well, as long as you know what you're searching for. But here they are listed under several categories, and I have gone into man-made, meaning artificial manufactured elements, and under that we have subcategories. I have opened some of them. So for example, we have fuse boxes outside of buildings, right? Electrical junction boxes, basically. We have ventilations, the grates, the grills of ventilations. We have light fixtures. We have wires and cables. We have pipes and tubes. We have even air conditioning units, the outside units of air conditioners. So there you go. You can find many urban stuff lying around in textures.com. Same goes for literally everything else. You can go into bricks and look at different types of bricks. You can look at the facades of buildings and try to extrapolate data from there. I mean, what can be placed on the facade of a building, on the facade of a let's say an interior or exterior space. You can find literally thousands and thousands of reference pictures in here, and I highly suggest you do that. You can even find solutions for the ground as well, just this proverbial floor of your level design. You can even put manhole covers and stuff like that, okay? But aside from that, the internet is full of stuff generated with these kinds of techniques, like greebly design. We call them kits, and we call this principle kit bashing. Basically, there's a kit of objects and you use them in several combinations with other stuff in order to create more realistic places. So you can find solutions for ancient or medieval designs. You can find solutions for modern urban environments. You can find solutions for slightly post-apocalyptic urban environments. You can find solutions for sci-fi. You can find solutions literally for any shape, any size, any style, any era, you name it. But please model your own. Don't use ready-made assets. You don't need to create like 30 or 50 or 100 of these objects. Like 10 is good enough. And if you feel like greebly design is unnecessary for your environmental design, then don't do it. This is just a suggestion. But if you're going to do it, we want to see you do it, not use somebody else's already available kit bash. Okay, don't buy stuff from the internet and use it in your projects. So without further ado, let's look at some of the ways you can approach this. Now, what I have here is the example I've already modeled in the class, but let's start from scratch and do it again. Now, I'm going to start with a simple fuse box, a junction box of sorts, which you can easily put on the side of a building. As you can see, there are many different types, and it doesn't have to be a fuse box. It can be a gas meter of sorts, for example, if that's what you fancy. It can be as simple as, you know, a simple electrical box with a pipe sticking out of it, maybe from under it, maybe from the side of it. Whatever you want. There are many different options you can go about designing this stuff, and you don't have to be super realistic. Like, we are not engineers, we're not trying to accurately represent reality or anything. Okay, it can be very simple. So As always, start with a simple box. Let's give it some values and try to imagine real values as well, especially if you're using metric system and you're going to start, you're going to design something photorealistic. Go with meaningful dimensions. Go grab a meter of sorts and measure stuff out here in the real life, and you will figure it out. So let's start with something like 30 centimeters. Okay. Let's do this. Maybe this. Okay. And all right. Let's grab a face. I don't know. Let's extrude it. I'm just making stuff up. I'm setting it and then extruding it again. Okay, not bad. Maybe let's do the same over here. Right, and let's do an indentation here somewhere. Maybe there's something written on it. Maybe it's this is a meter of sorts, and it's for reading certain values, like a gas meter, an electric meter, whatever, or there's something written on it. We don't know. We don't care. This doesn't have to be super realistic or anything. That's not the intention here. Okay, let's make an indentation like so. Okay. Do we want to do anything here? I don't know. I'm making stuff up. I have no idea what I'm doing. Okay. I'm just riffing here. Okay. Let's maybe do something like this. Okay. Let's assume that I'm happy with this thing, whatever this thing is, by the way. I have no idea. I can even fine adjust some of the stuff around here. Okay. Maybe let's do this. Okay. Let's assume that I'm happy with this. Alright, let's delete the history. We can adjust the details later, or we can go about doing it right now, but always be cautious of the fact that you're going to have to eventually UV unwrap this thing. Now, if it's a simple object like this, it's not going to be a problem after all. UV unwrapping these types of objects is relatively simple, it's relatively easy. And you can always use automatic mapping and go about, you know, joining most of these separated pieces together in the UV mapping. Let me show you what I mean by that. Is, for example, right now, this thing, we have extruded it a bunch of times, but Maya still remembers the initial state of the object, which was, to begin with, was a cube, right? So we have to unwrap this thing from scratch, and you can go about automatic unwrapping, but it's going to separate into a million different pieces, which is ridiculous, okay? So instead of trying to separate it yourself, you can separate it first and then start joining the pieces together wherever you feel like is necessary. For example, right, this piece is going to be separated, that's for sure, but there's absolutely no reason why these edges should be together. So you can select these edges, let's show the UV toolkit, and cut and sew them together, meaning stitch them together, okay? It's going to turn into a mush, no worries. Grab the UV shell and hit unfold, and there you go. You can go about fixing this stuff later on if you want. That is another approach. Instead of, you know, starting with an uncut piece and cutting it yourself, you can start with an almost fully cut piece and start stitching things together, and then unfolding them to get the correct, let's say, orientation. So let's do the same for here. Let's stitch most of these pieces. For example, we can stitch these, we can stitch that, and we can stitch that, and we can leave the other one empty. So when we go to UV shell and unfold, ta-da, it has unfolded very nicely. Let's do the same for anything else that might be unnecessarily cut away. Okay, let's sew it, UV shell, this too, and we finally have this piece, which in this case we're gonna sew these areas. And let's unfold everything. Let's go to arrange, grab everything, orient them. Okay, and for example, let's decide, just for now, let's decide on a textile density. Right now we are using a 4K map, and later on you're gonna see in the UV stacking tutorial, when we come to that, we want to put a bunch of these items. Let's say we have an entire system of electrical fuse boxes or whatever, or even we can put in bricks as well, as long as we have the space available. You can put all of your greeblies into one single texture package, because they are relatively small objects, and dedicating an entire texture space for just one of those objects is incredibly inefficient, and it is not optimized at all. Instead of doing that, we want to put as much stuff into one texture package as possible. We're going to even do that with the modular system as well. So thinking about that, for example, let's assume that we're going to use a 4K texture, and right now this is incredibly large. We are allocating 50 pixels, more than 50 pixels for just 1 centimeter, which is an extreme amount of detail which we won't need. Okay, so instead of doing that, we can say, okay, for each centimeter we're gonna have 5 pixels. Okay, so if we say set, oh, there we go, this is the amount of space that will be allocated. Okay, and we can gather them together, lay them out like so. Okay, Maya will automatically suggest laying them out like this. Maybe we should orient this better. Okay, you can even go ahead and start optimizing stuff just a touch, you don't need much. Okay, and let's rotate this, put it in here, and there you go. You have unfolded, you have created and unfolded your first greebly. Okay, now the best thing about greebly design is that what matters here is the amount of variation you can produce by coming up with the idea of a single object. Meaning that now that I have this available, let me call this something. Let's give it a code, right? So greebly, okay, for example, underscore fusebox1. This is just greebly underscore fusebox1. Let's create the version 2 of it. Okay, let me copy it and paste it, and the second version can be as simple as slightly modified dimensions of the original one. Let's assume that this was approximately 30 centimeters wide. Let's create a version that is approximately twice the size. Okay, only in one direction. You can do that, and it's very easy to do. You don't even have to play around with the pivot. You can use these absolute and relative functions, relative dimensional input boxes right here. So look at the pivot, or look at the orientation right now of the coordinate system. You can see that this is X, which means if we are seeing the color and the reading, that's the positive X side. So we want to push these on the positive X side to elongate this object, so to speak, and I want to elongate it by, I don't know, 30 centimeters, okay? I can just type in 30 here and it will do so, okay? Maybe this is a bit too much. Let's get that back. Maybe let's go with something like 20, okay? And you can do that for all other stuff as well. So for example, maybe I want to increase the size on the y-axis as well. Just type in 10 centimeters. There you go. Now I have the same fuse box, only it's slightly bigger, only it's a different version of it, let's say. You can add or remove objects on top of it, obviously. So for example, let's slightly complicate this. Maybe let's create, I don't know, another, let's say, opening on it, or maybe another protrusion on it. We can do that, okay? So let's grab everything. Okay, let me increase the clarity just a touch. All right, let me put it in here. Okay, let's assume that I am happy with this. Always check the alignment as well. As you can see, the alignment of the vertices are not good. Right now this is not a quad, or even though it looks like a quad, it is not a quad. So I'm going to break apart the edge flow in here to make sure that everything flies to an appropriate vertex. So everything turns into either triangles or quads in this case. Okay, this is good and all. So let's grab this face and simply, I don't know, extrude it just 1 centimeters, and that's it. You can do that. Now this object is obviously has differed in its UV map design, so let's fix that. For example, we have to first grab these pieces, okay, and break them apart. We have to cut all of these edges like we did with the other ones, okay? Cut. Let's grab this UV shell. We'll make sure everything is cut first. Oh, this one was missing. Okay, let's go to the UV shell. Let's grab this one, hit unfold. There you go. Now this piece has changed. The rest of the pieces, these haven't changed at all, but this one we elongated and modified, so we're gonna unfold it again. All right, make sure it's nice, and always go back to your texel density settings. So remember, we decided on 5 pixels per centimeter on a 4K map. Let's set it. As you can see, it has changed in size. All right, let's orient these things. Okay, nice. Make sure it is oriented well. Good. And we're going to gloss over this subject right now, but we're going to go into it in detail when the time comes to UV stack objects, multiple objects together. But the idea here is, and there's nothing wrong with knowing about this right now, is that you can, for instance, stack similar objects or identical UV shells and separate non-identical parts, but always, you know, collate them, so to speak, in the same UV area, in this case the 0, 1 area. Let's assume that this map will be reserved for all of the Greeble designs you will do for your own projects. You can bring together similar items, which in this case, this area and this area is the same. This object, this protrusion and this protrusion is the same. This side is not the same as this side. There you go, you have to modify it, but this side is the same, okay? So let's go over to this object and make sure that this UV shell is similarly unfolded. Oh, there you go. Its size has changed as expected, okay? So let's set it to the correct size. Let's orient it. Okay, there you go. Now, these objects, on the other hand, they haven't changed. These pieces, okay, this one, and this one is the same as the corresponding originals on the initial Greeble that we designed, okay? So they can stay in this place, right? They can be shared. The textures in this case can be shared if you want to, by the way. If you don't want to share the textures, if something different will be written or some other type of texture will be applied to these surfaces later on, you don't have to change them, okay? But in this case, if you want to modify the arrangement, we can grab both of them and then hit component selection mode and select the UV shell, and then we can simply arrange them according to the new setup. Okay, so there you go. Okay, there it is. Right? Now, this is the main principle behind UV stacking. Dissimilar objects, or not dissimilar, but individual objects, like one is the fuse box 1, the other one is the fuse box 2, but their UVs are arranged in a way to share the same layout, the same texture map. Okay, we're gonna go into detail later on, but this is the principal idea behind Greeble design. Creating a number of objects, a number of dissimilar objects speaking the same visual language. Mind you, they're going to speak the same visual language, but they will be crowded in size. Let's say we are trying to create a crowd. We are trying to create the chaos of reality, simply speaking, especially if you're designing a photorealistic or urban environment, which most of our environment is, right? So there you go. Now let's keep adding stuff to it, and they don't have to be complicated. Some of them could be quite easy to pull off, quite easy to design. So if we have fuse boxes, we will have cables or cabling, right? Pipes sticking out of the wall, carrying the electrical wires to these boxes, as you can see. Well, we can design some of them, and by designing, I mean just creating tubes, right? The idea behind this object is not very complicated. It's just a cylinder with the ends cut off in order to optimize it. So let's create a cylinder, a basic cylinder. There you go. And let's get close to it. And you don't even have to exaggerate the size. You can keep them really small. The idea behind Greeble design is keeping it subtle, keeping it subdued as much as possible. If you give it a big radius, it's going to read as a really large object. But I don't mean to do that. Okay, there is nothing wrong with a just 2 centimeter diameter cable. Okay, so let's, for example, do exactly that. Let's give it 2 centimeter radius or diameter in this case. Okay, and let's give it an appropriate height, like 50 centimeters, I don't know. And you can create different versions of it as well, like a short one, a tall one. Let's even decrease the subdivisions. 16 is more than enough, because this is such a small object, we don't need that many subdivisions. Okay, and let's delete the end caps, and the best way to go about doing that is just grabbing the entire thing, deselecting the middle and hitting delete, because we're never going to see the open end of a cable if that is not the intention. Maybe you need an end cap somewhere, but in my case I don't think that's necessary. So this is the 50 centimeter version. Okay, let's delete the history, and as you're designing your objects, always name them before things get complicated. Okay, so this is my Greeble, the pipe Greeble, electrical pipe Greeble. Okay, so this is the object it is supposed to connect to, maybe. So let's name this Greeble underscore pipe power. Okay, so this is meant for carrying electrical cables inside of it. Maybe later I will have different pipes, so I want to create this distinction right then and there. Okay, and this is going to be let's say 50 centimeters. Okay, and 50, you can even say 50 cm, and you can call this straight, or you don't have to call anything, because we understand it's 50 centimeters, so it has to be straight. Okay, so there you go. This is the 50 centimeter version. Right, maybe let's pull this to the side. Maybe there is a meter long version, so we can just do this. Okay, and say this is 100 cm. Okay, and then there's going to be, I don't know, a 40 centimeter version, right? And you can create variations, and the same thing is true about the UV space as well. Like, let's go to their UV shells, let's grab everything. First of all, let's unfold them, okay, and then orient them and then lay them out. Oh, you have to do them separately, unfortunately. Okay, and unfold, orient. Okay, so then, and if you do this from the beginning, it's going to be easier, obviously. Let's once again set the size. Okay, good. Now grab all of them and put them side by side. We can arrange them later. One thing to be careful, especially if you are designing pipes, which means the UV maps will have to be cut off at some point. For example, check this out. Assuming that the wall is going to be on this side, meaning that, let's draw a really quick wall here. Okay, so let's assume that there's going to be a wall here. Okay, and these things will stick to it. Okay, in that case, make sure that the texture separation line, this cut edge, is behind the object, is not facing us, because we are almost always going to see this object from this angle. Okay, so we don't want the texture to be wrapping around and joining onto itself right here. Instead, if that line is hidden away in the area where it will stick to the wall, the result will be much better. Okay, if there is any crime in that texture connection, you're going to be able to hide it if it's behind the object. Okay, so just so you know, right now it is almost behind, it is slightly askew, but whatever, that's an acceptable thing. I'm not going to play around with it, but make sure you are aware of that issue. In order to fix that issue, you can even, rotate these objects. So this had 16 divisions, right? So if we divide 360 by 16 divisions, sorry, that's 22.5. And if you look, we have 1, 2, 3 divisions. That gives us 67.5 degree rotation. If we do that, there you go, 67.5. It is directly behind. Let's do the same for here. Okay, now the line is hidden away. Okay, so grab all of these objects, delete their histories and freeze their transformations, and everything's dandy. Okay, you don't have to, sew an edge and cut it. If the object is symmetrical and if you can rotate it perfectly by known amounts, why not do that? Okay, so there you go. Let's continue with this pipe system. So for example, I need a corner of sorts, I need a bend, and the best way to go about doing that is creating a torus and chopping it away. Let me rotate this into a similar arrangement first. Okay, good. Now we have a radius and we have a section radius. The section radius in question is the radius of the pipe. Okay, and the radius is the radius of the turn of the torus. Okay, so let's give it a radius of, I don't know, 5, or you can even go higher, and this was 1 if you remember. And then the subdivision axis was 16, sorry, height was 16, and subdivision axis, let's give it something like 24. Okay, nice looking turn. You can even give it more detail if this is too crunchy. If this is too, jagged for your taste, you can go with 32, which will look much better. Don't worry about the poly count, because by today's standards, this is considered a normal object. This is not necessarily low poly by today's standards, but it is not high poly either. So don't worry about it. Okay, You can give it a radius of 5 centimeters. If you want to go, you know, with a larger bend, do a different version. I don't know. I'm going to go with this one for now. So let's delete all the unnecessary parts, because we only want this area right here. Now, okay, let's delete the history. Now here's the thing. When you are creating a torus like this, the UV map at first is going to remain or it's going to appear really nice. In this case, it's going to look very straight. But keep in mind, unfolding this will bend it in and misshape it in unexpected ways. Why? Because the area of these faces right here is smaller than the area of these faces right here on the other side of it, because the distance is greater here than it is here. And because of that, Maya will try to correct it in the unfolding procedure. Let me show you. It's going to do something like this. It's going to bend it and break it. And if you want neat packaging and you're not overly concerned about texture stretching in this area, which you shouldn't be, by the way, there's absolutely no way to unfold it like this. Instead, grab this object, okay? Grab this object and make sure this is set to 5. And since this is supposed to be in a similar arrangement, in a similar thickness, just make sure it matches, okay? By scaling it. Instead of unfolding it, use scale, okay? Nice. After that, look at your object and try to visualize the anisotropy, let's say the ratio of the short edge to the long edge. Check out that ratio. Check out these rectangular pieces and try to match them. Okay. In order to check that, you can even use the checker map. The checker map will give you an idea of how these objects should be oriented. Okay. Oh, let's check the edge first. Okay, this is what's wrong. Take a look. I was assuming that these ends were the ends of it. Apparently not. So that was illuminating. Okay, so let's put it in here. Make sure it matches. Always check your work against check the work of the UV procedure against the three-dimensional object. Using checker map in this case here and displaying it here, it works wonders. It immediately shows you the potential problem. So let's do this. Okay, there we go. Now it looks much better. Okay, so we can put it in here. That's good enough, right? And in this case, here's the issue. Do you want to, break apart the object and make sure the edge is located here, or does it stay here? I mean, it can stay under here, but in this case, let's assume that you want to break it apart. Let me turn off the checker map. Okay, I want to carry this edge over here. Now, I did that with rotating these objects 67.5 degrees. Well, I cannot do that here. I have to first break apart this object. Like, let's grab these edges, which I want them to be cut. Okay, then let's grab this UV shell, put it on the other side. Make sure these edges are the same edge. Check them. Okay, just get them as close as possible, because we don't want to, move that edge whatsoever. Let's sew them. Okay, that doesn't work because I've selected from here, sew, and there you go. I have just changed the cut line of the object. You can do that like so. Okay, then we can rearrange its pivot position. I usually like to put it in pieces in areas where they are supposed to connect to each other. And delete the history and freeze the transformations, and let's go back to 10 centimeter increments, and okay, and put it in here. right? And let's name this. So this is our wall. Let's delete it for now. So this is going to be, let's grab the name from here, pipe power corner. Okay, it's not an inside corner, it's not an outside corner, it's just a corner because it's a corner. Okay, and finally let's create a T-junction, for instance. And by the way, let's reposition the pivots for these objects as well. Okay, and for that I'm going to grab one of these pipes. Okay, and let's go with 10 centimeters is good, so let's go with this. Okay, and then let's rotate this like so, and make a copy of it, and then we have to increase the clarity and put it in here, and even obviously 1 2 3 4 5. Okay, that's good. Now we need to create this connection. You can create this connection with the boolean operation. The boolean operation helps you immensely in these types of situations, but you have to be careful about its usage and you have to prepare the object beforehand. For example, here's the idea. Both of my objects are open. If one of these objects were closed, if it was a regular cylinder, a solid geometry, the boolean operation would obviously fail. I'm going to give you an example. So here I have just created a new cylinder. It is approximately the same deal. Okay, let me give it a height of 5. There you go. Okay, and the subdivisions should fit as well, because take a look, all of the edges are ready to flow into each other, meaning that when they're connected, there are going to be vertices here and there's going to be an edge here, which is perfectly fine. But in this one, this has 20 sides and this has 16 sides, so they don't match. So be careful about these type of stuff. So let's make sure they match. But the problem is, as I have mentioned previously, this thing has caps on either side, meaning that it is a closed object, and this thing is open. Now when they're both open, let's go into mesh boolean union. There you go, we have the union menu. Everything works just fine. Okay, and if you delete the history on this, there you go, this is just locked in. Now obviously we have a fix to take care of here, because this vertex is creating a 5-sided polygon, a irregular pentagon, let's say, and I want to fix that. Okay, so I'm going to draw an edge right here, slide it here, and then basically connect it on both sides. Okay, apparently there's an edge issue here. Always check your work, so let's get rid of it by control deleting. Sometimes these things happen. Always check your work. Okay, and make sure that there are no stragglers, vertex stragglers around. You can always like grab the entire stack and hit delete, and anything with less connections than 3 edges will be considered an unstable vertex and will be deleted, so it will be gone. Right now everything seems just fine. Just to make sure, you can always hit merge vertices as well and delete the history. Okay, now this is the thing that we wanted to do in the first place, but let's take a look at an example and see what happens when a solid geometry versus a non-solid geometry are boolean together. In this case it worked. I want to show you an example where it doesn't, basically, and I hate it when it does that. Like, I hate it when it works as intended and not in a way, not in a, the kind of buggy way that I expected it would work. Okay, let me just grab one side and delete. Oh, it still works. Come on. You used to not work. Okay, but make sure sometimes one of the objects will disappear. That's what I'm trying to get at. I'm trying to replicate the problem, but Maya isn't letting me. But sometimes when you boolean objects, one of the objects might disappear. Well, I wanted to connect them. What happened to the other one? If that issue happens, a couple of things might be wrong with it. First of all, for example, one of the objects might be facing the other direction. In that circumstance, it's definitely not going to work as intended. Okay, now they are unioned, but as you can see, completely inside out. So this could happen. Or like I said, an open object versus a closed object boolean joint might not work. In those circumstances, check your work. Maybe you have to edit the objects just a touch at first, and then do whatever it is you need to do. Okay, let's clean up the object as much as possible. Now everything seems to be fine in here, so let's take a look at this connection. Okay, so let's grab the UV shell for this one and grab the UV shell for this one. Now obviously these are cylinders, and the simple action of cutting them will not result in a wonky unfold result like it would in the torus, because the faces can be laid flat without any issues. So in that case I can grab both of the UV shells and unfold them to get the correct let's say orientation. Oh, okay, so there is a problem with non-manifold geometry apparently. Let's fix it. Okay, now it's fixed. It did something. Okay, I believe there was an issue. It's expected. Boolean operations sometimes create non-manifold geometries. So let's orient them and set them to the correct textile density. And let's grab the different objects and you'll see the relationship. Okay, let me just grab everything. UV shell, come on. Okay. Finally. Okay. So you can arrange them however you wish. Okay, so maybe it's something like this. This comes here. This comes here. Right? Perfect. Okay. So you can start thinking about your arrangements as well. So there you go. Let's put this in a respectable position, which is perfectly fine. Let's delete the history, freeze the transformation, and there you go. We have a T-joint. So let's grab this and say this is T-joint. Okay. So you can create systems like this really easily, and all the while, you know, creating the UV maps alongside with them. Just open up your favorite music, play your favorite music, just hearken down, not hearken down, but hunker down, and you know, just work for a couple of hours. You will come up with beautiful sets. Okay, so let's create a few organic things. We have looked at manufactured objects, or maybe let me show you one more example. Let's try to create a ventilation. Okay, how you can create a grate like this, like as simple as possible. Okay, let's create something like this. Let's start with a cube, or we don't need a cube. We can start with you know, plain as well, but let's start with a cube. It will be much easier. Let's assume that this ventilation will be like 60 by 60, creating a large ventilation outlet. Okay, we're gonna only be working on a single face. Let's grab that face and hit offset, and let's do something like this, 5 centimeter outward. Okay, let me close the UV editor for now. Toolkit can stay open. Okay, Now what I want to do here is basically break it apart into several segments. Okay. Like 5 centimeter increments. I'm going to arrange them later, so I'm not overly concerned with the arrangement for now. Okay, and let's get 5 centimeter increments, apply and close. I mean, we can delete the rest, we don't need the rest. Why are we playing with this? Okay, alright, and just drag them and snap them to the grid. Okay, perfect. Delete the history. Now obviously you can add more details. If you look, the grates themselves have flat faces. What I mean by that is they have flat faces in front of them. It is not fully sharp. You can do that if you want to, but you don't need to. And a good way of doing that is just you grab all of these edges, okay, and simply say bevel, okay, and then you can decide on poly bevel size. For example, right now it is 0.5 centimeter. The offset is 0.5 centimeter. Okay, that's perfectly fine. So I can grab all of these faces, extrude them like so, -4. I don't know, I'm making stuff up. And then grab the underside edges, and when I say Control Delete, ta-da! Okay, nice looking geometry. Okay, now I can grab all of the front faces like so, make sure nothing is selected, and let's extrude them. Okay, and I don't know, maybe extrude them 2 centimeters. Okay, good. Grab the outside edges, bevel them like so. Okay, and I even want to push these bevels a little inwards. Not a symmetrical bevel, but larger on one side. That's the kind of bevel I want in this case. Okay. Okay, nice looking bevel. Make sure this is on the centimeter itself. Okay. And there you go. Now, here's the problem. Two things I want to talk about. One, while this object is designed nicely, there's a problem with it, because right now we are designing a greebly that is not only additive, but in essence it is also subtractive, meaning that this ventilation has an opening inwards. I mean, these shafts, for example, is opening inwards, meaning that if there is a wall here that is going to collide with, or that is going to stick onto, let me create a wall really quickly once again. As you can see, the wall itself will immediately cover the openings of the ventilation, right? This is a subtractive greebly, meaning that if you're going to use it like this, you have to prepare the space. You have to open up a space so this can fit in. Your modular design will have to accommodate for it, or this greebly will not be a standalone piece, but it will be a piece that will connect to some of the modular items as in the process of designing them. Okay, so this is that type of a greebly. A similar thing would be, for example, the manhole covers, because if you look at manhole covers, most of them have indentations around them, meaning that they are lower than the floor itself, lower than the ground level itself. So unless you're creating an opening on the ground level where you can place these greeblies in, The ground itself will be covering them, unlike the pipe system or these junction boxes, these fuse boxes that we have created. Okay, so one way of fixing this issue is, if you don't want to create a greebly that requires a hole on the wall or hole on the place that is going to be placed on, you can, let's maybe hide this, you can exaggerate some of the details. Instead of this object protruding just by 2 centimeters, you can make it protrude even more. So maybe let's grab these values, okay, these areas right here, and push them backwards, or maybe let's keep them intact and push these instead. Okay, you see what I'm trying to get at? Okay, maybe let's grab everything in here. Okay, so we're gonna push them in this direction. Okay, so hide the crime, so to speak. So this is Z direction. Let's push them in Z direction for 2 centimeters, and then I'm also going to grab these and push them as well. It's not going to be 45-degree angle, but I can even push them even a bit more to fully clear that area. Now let's slightly modify this. So this is maybe 1. Okay, now this ventilation shaft will stick out from the wall as a more robust object. It is not as thin before. It was very thin beforehand, but right now it is sticking out more. But as you can see, it is not colliding with the object. The only thing that is doing any collision is its outline, right? Which isn't a problem for us. Previously, the wall entirely collided with the openings on the grate itself. Okay, so be careful with these kinds of situations. You can do similar things with the manhole covers as well. For example, imagine you're designing a manhole cover. Let me really quickly demonstrate. I'm not going to, put so many details on it. Let's design a manhole cover really quickly. Okay, so let's give it a radius of 30, and let's give it a radius of 64. Oh, sorry, subdivision axis of 64, and it has a height of right now 2. Okay, now usually a manhole cover, let's assume that this is our ground level manhole cover, like most objects that are designed to remain flat on the ground, does exactly that. They remain flat on the ground. Okay, so let me grab a bunch of caps. Okay, let's grab this edge, for example. Put it in here. Okay, and I'm going to just grab these edges, Control F11 and delete, because I don't need the underside of it for my demonstration. Okay, and I don't even need this edge for now. Okay, this is a basic demonstration. Let's create an indentation here, meaning that I'm going to first of all create a bevel. Let's, for example, assume that this offset is 1 centimeters maybe, or let's keep it at 1.5. In order to grab all of this area, I'm going to just put a sacrificial edge loop, which means that when I hit Control F11, this entire area will be selected. So I can, for example, do this. Okay, I mean, this is the indentation we're talking about. I have just created an indentation, so I can go back and Control Delete and remove this edge. Now, an ideal manhole cover would look something like this. Okay, and let's delete the edge as well. Okay. Okay. So this is what a manhole cover is supposed to look like. So when I create a ground plane, it remains flat with it. But here's the issue: we have lost that indentation. Okay, the kind of indentation these manhole covers have around them. Check it out, like every single one of them have them, and there's a good reason for that. These manhole covers are supposed to open, so there is a disconnect between the part that opens and the frame of it. Okay, that indentation, if you want it as a geometry, it will be removed. Okay, it cannot remain flat. So in that circumstance, you can obviously, once again, exaggerate the detail. Okay, maybe not even this much. Okay, let me just increase the clarity. Okay, so let's do this, just 1 centimeter. Okay, let's even increase the clarity even more. Let's go to 5 millimeters. Okay, and we can, you know, do this and even give it a bevel. Okay, and then push this area inwards as much as possible. Okay, to flatten that profile. Now this is a made-up manhole cover. No manhole cover would stick from the ground like this unless it's in Turkey. Haha. It shouldn't. That defies the purpose of a manhole cover. It should remain flat with the ground. But in this case, we can keep this greebly additive, meaning that you can add this to a flat surface and it will not collide with it. It will remain on top of it, okay? Because geometries cannot behave like decals in this circumstance. A decal is just, handled through draw orders, meaning that the texture, the shader on the wall is drawn first, and then the decal is drawn on top of it. It is the last in line in the draw order. But the geometry is geometry. When it collides with other geometry, there is no order to it. You cannot play around with the order. So you have to make it additive by exaggerating its detail or exaggerating its protruding effect so that it remains on top of the flat surface no matter what. Okay, so be careful with that. Another thing before I move on is that, as you can see in the first example, I have beveled the corners. Now this is a choice. If you want to bevel the corners, just that's fine. Be my guest and do that. But later on, in another tutorial, I will be showing you the bake trim approach. And in the bake trim approach, this is unnecessary. You don't have to resort to doing this because the bake trim themselves will be able to do this. But if you want to, you can still do that. Okay, you can easily go into any number of edges. And you don't have to do every single one of them. Like there's no reason to bevel this, but maybe only bevel these corners. Okay, only bevel the corners of the edges of the larger objects or the larger geometries. Okay, this is always a choice. These are all your geometric choices. Okay, and this one as well. Apparently, hopefully that's everything. Okay, let's go bevel them. And obviously we have to say this, and you can even put smaller bevels on them. This will add some more visual interest to this, not maybe visual interest, but it will start to read better because these edges will start catching highlights, which is what they're supposed to do in the first place. But you can easily do this with normal maps as well with the bake trim approach. But you can combine the two of them as well. But I highly suggest the bake trim approach. There's absolutely no reason why you should be beveling these corners or beveling these edges. Not to mention that it will complicate the UV process as well. Now you will have to go in and fix all of these edge alignments so that the bevel itself works. You will be creating additional faces that you need to play around with in the UV unwrapping procedure. Okay, so it's entirely up to you, but know that many different approaches exist. Okay, so finally let's create something organic as well. So we looked at man-made objects and there are lots of them, so I'm not going to go into details. You will have to pick and choose what you want to do with things. Okay, I mean, you can even design a light fixture, but that will be unnecessary because, I mean, this is a fairly simple geometry. You can discover that on your own. Okay, but instead I want to look at, for example, more organic looking object like this. For example, a stone piece or a brick piece. So how can you design a brick like this? I mean, this is a relatively small object It is not a hero object, it is just clutter. And let's assume that there are 5 variations of bricks and you will be cluttering them, or maybe some of them will stick out of the wall, like in this case, in this example right here. Maybe you will create an arrangement of bricks to further spice up your environment design. Well, how can you go about doing that? It's relatively simple. My approach is something like this. First of all, create a brick. I mean, you have to create a brick, right? Let's do that. And by brick, I mean, well, what is the brick dimensions? You can always search for things like that. Now, maybe it is not apparent how large a brick really is, or how small a brick really is, but like, what is the accurate dimensions? But why not search for it? Brick dimensions. There you go. Like, these are inches, but here's a standard, for example, brick dimension, like 65 millimeter, 215 millimeter, 112 millimeter. I mean, there are different options as well. There's no one uniform brick size, but our idea of a brick in Turkey is, as you can see, there are many different dimensions. Our idea of a brick in Turkey is something like 10, 5, and 20. That is the basic dimension. It is not exactly that, but you can do that. Okay? So we are not trying to portray reality to its finest architectural detail. So you can go about something like this, like height 5, width like 20, and depth 10. Okay? This is a good enough brick. You don't have to overcomplicate stuff. Okay? So let's increase the clarity, and obviously it's going to be 2.5, and then I'm going to hit insert and place it down the center. Okay, and then I'm going to bevel everything and make that bevel really small. So I don't even have to play around with the offset length. Instead, let's play around the fraction. That's good. Okay, so let's delete the history, freeze the transformation. Now the next thing I need to do is, well, for example, first of all, let me make copies of this thing, or at least make one copy so I don't lose it. What I'm going to do is just go to mesh and retopologize. Now, working with retopology will allow me to, take this extremely precise object and make it slightly more organic, like the one we see here, and trying to replicate with the warbled edges and slightly broken nature of it. I'm trying to replicate that. Like, I had no intention of creating a high poly geometry out of it, and I don't think it's worth it to go ahead and try to create a high poly version for sculpting. That's wholly unnecessary. But while we are at it, let's try to model these circular openings as well, these cylindrical openings as well. Let's try to do that. Okay, so without retopology, let me create another copy. Okay, let me create a opening. So let's create a cylinder. I'm going to make the cylinder even less detailed than the other ones, like 8 faces. Let's give it a slightly bigger radius, maybe even 2. Why not? So let's do this. Okay, and let's grab these faces, delete them because we're not going to use them, and let's do that. Let's do that. I mean, the face underneath, we're not going to bother with it. And the face, let me delete this. Okay, and then grab these edges, extrude them outwards. Since this thing is inside out from my perspective, so I need to switch it. Okay, like so. Okay, that's good. So what I'm going to do is simply drag these edges to appropriate locations. so. Okay, duplicate it. Okay, okay, all right. That's nice. Okay, let's combine and merge the vertices. Okay, then grab the vertices, push them here by referencing the vertex. Nice. So in order to match these things together, I need to create these edge loops. That's good. So let's go ahead and grab these vertices and match the receiving side on the cylindrical contraption. Okay. And one more thing. Let me delete this ground plane. It's creating more issues. Okay, so what I can do is just grab the underside, deselect the unnecessary, delete. Okay, now grab these vertices, drag them here, and then delete the history, Control D to duplicate and mirror it like so. So basically I created a copy of it underside. Okay, grab everything, combine, merge the vertices, grab these edges, I don't need them, Control Delete to remove edges and vertices. Okay, that's good. Delete history, reposition the pivots, and there you go. You have a standardized brick, which is a very low poly right now, but that's the point. Okay, so let's duplicate it one more time and let's try retopology on this. Okay, now let's remember the retopology standards. Like regularity, for example, they come with their explanations. So regularity concerns how many quad faces we are using. The more irregular the object, the more singularities will start to happen, like the pinching areas, vertices with more than 4 connections. Okay, face uniformity, in this case, the overall differences between the sizes of faces, meaning that small quads and large quads will happen when the uniformity is low. Okay, and anisotropy is the rectangularity of the faces. The more the less anisotropic the setting is, the less anisotropic the face is. It will start to turn into a square, basically. Okay, so I want, for example, regularity. Okay, like this amount. I want them to be uniform and I want them with low anisotropy. Okay, but target face count 50,000 is way too much for this. Okay, so let's go with something like 1,000 or maybe even 500. Okay, chances are, since this is a very small object, it's going to say, oh, I don't like this. Ignore. Okay, and it's going to result in something like this. It's a bit balloony right now. It seems inflated like a balloon. Okay, let's try it again. There's nothing. Oops. Let's try it again. In this case, let's give it more faces because it's going to, make it better. Much better. It's less balloony looking right now, and that's perfect. Okay. Now I can make copies of this. Okay. That's fine. And let me create a master copy of it here as well. And then go to sculpting. And for example, instead of trying to, push and pull the object, I can play around with it using stamp. Okay. So let me go to tool settings. And this is perfectly fine. Okay, I mean, you can pick the stamp, and here we have sculpting stamps, right? And there are many options, but this was nice. Okay, I don't know what this was. Yeah, rubble, that's good. Okay, now let's try it. I don't know how what the strength setting and the size setting will do in this case, but let's try it. Oh, that's a bit too much. So strength, let's lower it real quick. Okay, and that's too little. Let's try different settings. And maybe let's increase the size so it applies it to a larger area. Okay. What I'm doing basically is, trying to create some, let's say, irregularities on the surface. Okay. Something like so, something like so. Whatever. Okay. There we go. And by just playing around with this object, you can create variations on it, and obviously you can do to the other bricks as well. And you don't even have to go create a higher poly version of it. Well, if you want to, you can still do that. Obviously, you make a copy of this, smooth it a bunch of times, like 3 or 4 iterations even, go with the sculpting tool, add a bunch of details using stamp or whatever, okay, and then match them together in Substance Painter and create variations again, obviously. But the idea behind greeblies, as you can see, is create multiples of the same kind of object. So without repetition, you can use like 20 or 30 objects without the player realizing that this environment is made out of several repeating pieces. That's the idea. That's why we create one fuse box, but then using the same base, we create multiple versions of it, like make a smaller version, make a dual version, I don't know, make stuff up, okay? You don't have to design something over and over again, just work with its dimensions, make it slightly different, and during the texture application process, maybe sometimes change the colors or change the level of damage on it or whatever, okay? So the variation is hidden in details. You don't have to do something really grand in order to create that variation. The number of objects in this case is more important. Quantity over quality in this case. Usually that's not the case. Quality is over quantity is always the accepted motto, but in this case quantity is far more important. So go ahead, design yourself a bunch of rocks like so. Where are my rocks? There you go. These are just a bunch of simple objects, simple geometries, arranged in various organic looking configurations. They are probably smoothed or sub-D'd or maybe retopologized. They have little sculptural details on top of them, and then using the same kind of a material on Substance Painter, somebody applied this stonework texture on top of them. And none of them is a high quality object or an interesting object by itself. As a set though, there are so many pieces here and so many different orientations you can work them. There's a tremendous amount of complexity, perceived complexity in this kit, okay? But when you look at it, it's just like what, 11 pieces, like 4, like 12, 15. That's just 15 pieces. That's it. 15 pieces and incredible amount of variety. You can use like 150 of them and you still wouldn't realize that every piece is repeating 10 times. Okay? That's what I'm trying to get at. So this was Greeble design. Hopefully you understood the process. You understood the basics. You understood the idea behind creating something with additive methods, meaning that it is going to stick to an object and is not going to necessarily have a room for it allocated in the original design. So you have to sometimes coerce objects to behave in unrealistic fashion, like a vent slightly thicker than it needs to be, or a manhole cover sticking out of the ground so it doesn't collide with it, whatever. And when it comes to texturing, always be aware of the situation. Okay, it's easier to do things earlier on the modeling stage than later, because once you UV unwrap this thing, when you create variations out of it, it will be easier to unwrap or modify the UV maps of other ones than do it from scratch. So keep that in mind always. So there you go. I'll see you in the next one. Good luck.